Hey guys, welcome back. We are looking at another dynamics problem. I am here to grace you with some more of my artwork. As you can see, it's beautiful. I worked all day on it. And in this problem we have a two-stage drum. We've seen this before. Same drum. And in this particular case, the drum is rolling along the surface, not sliding, and it is the cord is being pulled at a velocity of 8 inches per second at an acceleration of 30 inches per second, and we are asked to find the accelerations at points A, B, and C. And so let's get to it. If you can recall, the last time that we looked at a problem like this, we used this idea of the instantaneous center of rotation. And so here, B is not moving. A has a acceleration and a velocity there. And so if you can imagine just drawing a line from A to B and beyond, then when you get to G, the center, then the vectors scale up, right? So this is G, right? And we can use this principle because the drum is not sliding, right? It's not sliding on the surface. So we can actually use this to get V sub G and A sub G, right? Which is useful information. So V sub G, let me add this in real quick. So this distance here, right, from A to B, this is 2, and from G to B, this is 5. We're going to need these. All right, it's easy to get confused when you're going, whether you're going from G down or from B up, so I like to write it down. So VG over 5 is equal to VA over 2, right? This equal triangle idea. And this, so this is 8 over 2, so this is 4, right? And if we multiply 5 across, then that gives us that VG is equal to 20, and that is I, and that is negative I. All right. Similarly, we can do this for AG, right? So AG over 5 is equal to AA over 2, and this is given as 30, so this reduces to 15, and if we multiply 5 across, then that gives us that AG is equal to 75 I in the left direction. So let's make that negative on this side. Okay. All right. So we can use AG to, well, actually, we could use VG to get omega, right? So VG is equal to omega R. Since we know the direction, we're fine there. So 20 times, we need to rearrange this to get omega, because that's what we're after. So omega is equal to VG divided by R. So that is 20 divided by 5. So that is 4 radians per second. And that is going that way. Sweet. So now I like the idea of attacking B first, because B isn't, there's no translational component to it, right? So there is only the acceleration to be in the J direction, right? And I think we can just look at this. Yeah. So just know, I guess let's put a note to ourselves here. We'd say that A, B, actually we don't even need a note. Nah, no notes. Okay, A, B, J, I'll put it that like that. What is that? That is AA plus, and then we get the normal and tangential components, right? And we need to calculate those. Well, I mean, anything that is in the I direction doesn't contribute, but we need to add those in. So that would be alpha, right? Which we don't yet have. We don't know what the acceleration is yet. So alpha, and this is in the k direction, crossed with r, and in this case r is the vector from A to B, right? Because we're calculating B. So this is going to be crossed with minus, let's put this in here, minus 2j, okay? And then the normal component, right? So minus omega squared, and what is that? That is 4, so minus 4 squared times r, and this is, again, minus 2j, okay? And alpha A, so I think we only have one of those components, so alpha A is, or excuse me, not alpha A, AA is 30i, right? And I think that's minus, so minus 30i. That is what is being peeled off of here, but there's also a normal component, right? So we'll just say plus a sub n, and that is definitely in the j direction, right? And then plus, now alpha, so k cross j is, k cross j is negative I, so minus, say minus 2 alpha, but this is already negative, so it's going to be plus 2 alpha in the I direction, right? Minus, and then 16 times 2 is 32, and negative times a negative is a positive, so plus 32j, right? And that is our acceleration in B. So we should solve for the I direction. Let's do it over here. We'll say the I direction, right? So anytime you solve, anytime you are looking to end up solving in one direction, solve the other one first. It's faster. Right, so what is this? This is I direction. Okay, we have minus 30 plus 2 alpha equals 0. So that means that alpha equals 15, right? 15, and since this is a positive number, then this is rads per second squared, and that should be that way, right? Okay, sweet. So now in the j direction, not that I don't think that really told us anything here, but in the j direction, we have a sub n. We're going to need to equate these, aren't we? All right, so a b j equals, what we have here, this is the j direction, so a sub n j plus 32. Right? Not sure that we can go much further with that. Okay. So the other thing that we can do is we can solve for the acceleration of B using the g parameter, right? So what does that give us? Let's try that. So a sub b, still in the j direction, it's going to be equal to a sub g, right? Same thing, plus alpha, k crossed, and now this, instead of being negative 2, it's going to be times a negative 5, right? So alpha k cross with 5, and we know alpha is 15, cross with, and this will be negative 5. Okay, and that is in the j direction, and then minus omega is still going to be 4 squared and minus 5j. Okay, and a sub g, we have that value, so that is minus 75. Okay, and the let's multiply this out. This is 15, this is 75, and recall that it is negative, so this will be minus 75, and this is in the I direction, plus, because negative is positive, so plus 75I minus 16 times 5, I'm not sure what that is, but no, wait, that's 40, or 80, I'm sorry, that's 80. 80 minus is plus 80j, so these actually cancel each other out. There was an I there, so A B is equal to 80j, which is good because that's what my notes tell me. Alright, and coming back to here, that means that we also have the value for the normal component of A, right? So that's handy. Oh, so let's see. Let's see if we can do A. Let's do it this way. Let's say that A is, let's say AA is equal to, this worked pretty well. Let's try this again. So let's say AG, then plus omega, so this is 15k crossed with, now it's, instead of it being negative 5, it's negative 3. So cross with negative 3j there, and then minus 16 times negative 3j. Do we have values for that? I think we do. This is, what, this is 75. So 75i, okay, and that is a minus 75i. So yeah, this is, let's see, this is 45, so that is going to be minus times a minus, so this is plus 45i, and then 16 and 3 is 48, right? So plus 48j. So then the acceleration of A is equal to, looks like minus 30i plus 48j. Is that right? I think so. Okay, sweet. Well, that's 2 down, 1 to go. Coming for you, see? Alright. Here we go. Alright, so now we want A sub C, and it is from G to C. This is, the vector here is a positive 5i, right? So again, A sub C is going to be equal to A sub G, which we already know is minus 75i plus the cross between alpha So alpha is 15k cross with r, and r is I5, so 5i, okay, and then minus omega squared, which is 16, so minus 16 times 5i. Okay, so let's see, what is this? This is equals minus 75i, and then that is 75. Ki is j, so plus 75j, and then minus 16 times 5 is 90, so minus 90i. So that looks like a sub c is minus 165i plus 75j. Let me check. Let me see if I did that right. If not, I'm correcting it. Let's see. 75. That 5. Oh, that's not 90. That is 80. There we go. 80, which makes this 155. I minus 155, 75. There we go. And there you have it. So not too bad. Got a little funny. I may come back and look at this because this is just a very interesting finding. Well, let's see. 80. Just for fun. Let's look at it. So a sub b. What we're saying here is that a sub b, or in the normal direction. According to this, in the normal direction, a sub n should be 80 minus 32, and that is 48. There it is. Ha ha. Normal direction, 48. So there you have it. The math works out. So anyway, that was a fun problem. I hope you liked it, and I hope these videos are helpful for you. If they can be improved in some way, please leave a comment, and I will definitely take a look at it. And I will see you in the next one.